Walk into many modern university halls, and you'll find a massive projection screen playing a 90-minute lecture to a room of exhausted students. We treat students like hard drives waiting to be filled, but the human brain can only process so much continuous information before it shuts down to protect itself from cognitive overload. The problem here is the strategy, not the screen. Hitting play on a feature-length recording without a specific instructional plan turns an active learning environment into a passive waiting room. To fix this, we look at how the brain actually processes information. This model illustrates the theory of dual coding. It shows two distinct pathways, one for verbal data, like spoken words, and one for visual data, like moving graphics. When an educator targets both channels simultaneously, the brain creates a much richer, longer-lasting mental representation. Now, pair that cognitive science with modern AI production tools. A dense, abstract concept that usually takes 40 minutes to explain at a podium can be compressed into a highly focused visual narrative. Designing media with this level of intention is how we stop competing with digital distractions and start capturing our students' absolute intellectual focus. The most vital work in educational media happens long before anyone presses record. An effective academic video requires an educator to spend about 70% of their total effort purely on instructional design and script structure. This pyramid represents Bloom's taxonomy, the metric dictating video type and length. For foundational definitions, we build a micro-learning video, capped strictly at 6 minutes. Moving up to analytical thinking, we design 12-minute case study videos, allowing for deep critical analysis. To accelerate this planning, educators can feed raw academic notes into language models. The AI instantly organizes the material into a precise 3-act narrative structure. Forcing every minute of footage to answer a specific cognitive objective strips away the bloat. The student doesn't suffer from fatigue because every second serves a deliberate academic purpose. Once the blueprint is set, we have to actually make the video, and there is a persistent myth that you need a Hollywood budget or a dedicated studio to do this effectively. The reality is much simpler. A smartphone propped on a desk, the natural light from a window, and a $15 lavalier microphone are all you need to capture clear professional material. But the real advantage comes from AI amplification. Software now handles the technical friction that used to require a full production crew. If an educator isn't comfortable on camera, they can feed scripts into an AI video generator. The system outputs a photorealistic avatar delivering the perfect pacing, natural expression, and direct eye contact. We can also use prompt-based animation to instantly visualize abstract ideas. A text prompt generates a microclip of molecular bonds forming, or a shifting economic curve, making the invisible visible in seconds. When we eliminate the technical barriers of lighting, editing, and animation, the professor's energy remains exactly where it belongs, on delivering high-value intellectual substance. Exporting the final video file is only the halfway mark. The true effectiveness depends entirely on how it is integrated into the class. We start with a before strategy. Before the student hits play, we provide a clear viewing guide that activates their prior knowledge and explicitly states what they need to look for. This diagram maps out the during phase. Notice the vertical markers along the timeline. When the playhead hits a marker, the video pauses and prompts the student to answer a question or reflect on the concept, forcing them to actively engage with the content rather than just letting it wash over them. Finally, the after strategy. The moment the video ends, we capitalize on the momentum by moving immediately into high-level processing, applying the concept to a fresh case study, or initiating a class debate. This framework surrounds the video. It turns an isolated media file into a connected, highly active learning ecosystem. Compare that to the dark lecture hall we started in. This is the flipped classroom. It is a dynamic hub of active peer-to-peer collaboration. Because the student successfully absorbed a tightly structured 7-minute explanation before they ever walked through the door, the precious in-person time is completely liberated. We no longer have to spend an hour standing at a whiteboard doing basic data transfer. We spend that hour testing boundaries, dissecting complex arguments, and solving problems together. The digital workflows and AI generation tools we use to build these resources do not replace the educator. They act as a lever, exponentially amplifying the reach of their subject matter expertise. By approaching media with intentional pedagogical design, we stop fighting for attention and start building a direct, frictionless bridge between our academic knowledge and the minds of our students.